Incident response and the SOC tools. So here we are mixing between the tools that can be used by the incident response as well as the security operations center in the organization. So some security measures or some security tools that are used in the context of security operations center and the context of the incident response is, for example, network intrusion detection system or host intrusion detection system. What is the intrusion detection system? It is basically a knowledge-based device. Knowledge-based means that it has a signature database, and using this signature database, it can check the traffic or monitor or evaluate the traffic. And based on this traffic, based on the pattern, it can detect if there is something going wrong or not. Intrusion detection systems can only detect, which means it cannot take a preventive action. It can detect the problem and notify the incident responder or SOC, and based on this notification, SOC can do the triage and can do the response accordingly. Intrusion detection systems is or can be host-based or network-based, which which means that host-based is a software client installed on the end user device. So it can protect the user whether it is online or offline. What do I mean by offline here is that user is outside the corporate network, took the laptop or mobile device and working remotely or from home. So host-based IDS can provide protection in that case. Another control is known as the intrusion prevention system. So as the name implies, IDS and IBS basically work using the same concept. They have a knowledge base, they have a database, and they are evaluating network traffic. And based on this traffic, if it match exploitation of security vulnerability, they will give an alert. But in case of IDS, it will only give an alert. But in case of IBS, it will give an alert and prevent. It is worth to mention that IDS solution can work as an IDS. We do not have right now a solution that can work as an IDS only. But I believe there are some exceptional in this case. Don't take this for granted. However, the decision of implementing or how to design or implement the IBS in your network will decide whether this device will be able to take action or not. For example, some organizations are basically do the following. They have their network router, they have the switch, and after the switch, they have, for example, the internal service or server. So they basically do what? They basically take this port, connect it to an IDS or IBS device, and mirror the traffic, whatever coming from the router to the end user, send a copy from this traffic to the IDS solution or IBS solution. In that case, even if this solution can have some enforcement or some prevention capabilities, because of the location of the device according to the network structure or network topology, it will not be able to take an action. That's what do I mean by that the decision or the IDS is not influenced only by how the control or how the solution is performing, but also could be influenced by how you are implementing the solution. In critical infrastructure, such as the OT environment or industrial control system environment, there is no tolerance for having a false positive alert from the IBS because false positive will mean that traffic will be dropped. And this traffic might be related to some critical activity related to increasing the percentage of some kind of gas in the water during water treatment. So we cannot tolerate such prevention or such outage. That's why in OT environment, in operational technology environment, the security architecture or security designer might decide to implement the IBS in this way, in the way that I'm explaining here on the screen. Why? Because they need visibility. They do not need action. And they will treat any alert to come from IDS in that case as a priority, regardless what is whether it is minor or not minor. So intrusion detection and intrusion prevention systems are basically designed to prevent against network attacks, such as the DOS attack, such as buffer overflow, such as a wide range of intrusion prevention or exploitation that can be done through the network. Intrusion prevention system can provide virtual patching for security vulnerabilities. If you have an OS and this OS is vulnerable or let's say vulnerable against Log4j vulnerability, running like an old Log4j library, and this library can be exploited using whatever, an exploit code. IBS can have a signature that tell it whenever I see this traffic is mapped to exploitation of Log4j block. This is how IBS works. So IBS solutions can be knowledge-based or can be behavior-based, and the difference between knowledge-based and behavior-based is obvious. In knowledge-based, I should have a static database which include the pattern, the details, the key aspects that I need to know or I need to see in order to treat this traffic as a malicious traffic. But in behavioral-based detection, we are basically detecting or taking decision based on the behavior, such as this traffic is weird. This traffic, for example, is targeting non-working service, or this device in the network is performing unnecessarily scanning with 100 devices at the same time. This is something wrong. So you need to shut down any communication between this device and any other device that it is trying to communicate with. Another security measure that is being used by security team, operation, and incident management, incident response, and SOC is the honeypot or honeynet. So honeypot is like a trap. It is like a device that looks to be important, but basically it is not an actual service. It is a device that has been implemented intentionally to capture the attacking attempts. So when the hacker accesses a network or establish a foothold, they will do a scan, and they will find a website, a server called critical database or BII database or CHD database. So the name looks tempting. So the threat actor will start in performing some attacking techniques to gain access to this database or to this honeypot service. As a result, security team will get notified immediately that there is someone managed to access to our network, and right now he or she is trying to gain access to our honeypot. In some complicated scenarios, we may not find single honeypot, but we can find a honeynet. And what is the honeynet? It is a combination of multiple honeypots, switches that are acting as honeypots, firewalls that are acting as honeypots. It is like a shadow infrastructure that is totally fake. And the goal of this shadow infrastructure is to take the hackers away from the original production to a trap or a black hole where they will be, let's say, monitored. The goal of honeypot is not only to detect the attacker, but also to detect and understand what is the tactics and techniques that used by this hacker, so we can link the attack to a specific country or a specific threat actor group. This is the idea of honeypot and the honeynet, and it can work very well as a detective control. Of course, we also aware about malware or anti-malware, which is a signature-based or could be a behavioral-based. Security team can also utilize whitelisting or blacklisting application control to allow only certain files or certain types of executable files to run on our devices. Also, firewalls can be used to perform network segmentation, and usually intrusion prevention system is coming as a module embedded inside the firewalls. So firewalls come with an IBS engine embedded in the firewall. But basically, most of the firewalls are like this right now. Later or back to 10 years ago, this was like an additional benefit. But right now, most of the firewalls are categorized as next generation firewall, which can provide extra services. Sandbox is another security measure, and the sandbox is not related to programming because the term sandbox might relate to the test machine or the test environment where we can test the new source code or a new software. But basically, sandbox in cybersecurity use the same concept. Sandbox is a controlled environment which is basically run on VMware and include multiple virtual machines, one for Windows, one for Linux, and one for Windows with Microsoft Office, whatever you choose. And what happens is when your antivirus solution detects that there is a file and this file does not match any information or does not have any information in the knowledge base detection, we can configure our antivirus solution to share this file or send a copy from this file to the sandbox platform. And the sandbox platform is configured to execute this file on all of these virtual machines. Because if this file does not work on Linux, it might work on Windows. If this file does not work in Windows 11, it might work on Windows 7. And based on this execution, we can take a report from each one of these systems, which is something that can be done by the sandbox platform. And based on this report, we can understand what was the behavior of this file when it got executed. Does it try to modify some registry information, create a new user account, do something malicious? Based on that, we can take an action after then and update our antivirus engine database at the provider side by such information that mans pay attention whenever you see this hash. Once again, this hash is a malicious file because I did my investigation on my sandbox and I found this file is malicious. So sandbox as well is a commercial solution that can be used by multiple organizations. So SIM solution is another security measure that is concerned about logging or collecting the different logs, and it provides central logging functionality, provide indexing of millions of logs from multiple of sources, and do normalization for all of these logs, which mean when I generate a log message from Linux and Windows and so on, all of these log messages will be different in the structure because each log message is different according to what is the system that generated this message. SIM solutions has the capability, or security incident and event monitoring solutions has the capability or have the capability to normalize this log message, remove information that is not relevant, and keep only the important information like source address who sent this log, message timestamp when this log got generated, what is the severity level according to the sender system, and what is the log message. And by doing so for all kind of logs, we can have a standardized way for how we can see the logs. And then same solution can apply use cases to aggregate these logs together and try to figure out if something wrong is happening or not. Because same solution will be able to check logs from endpoint, from network, for email. So if we can link these three logs together, we can use the use cases to establish or to identify how attack has been happened or conducted. Log retention of logs in the SIM solution is a compliance requirement. So you need to identify whether you are falling under a certain regulation or a standard that require you to keep the security logs for a certain amount of time. So log retention can be 1 year in case of PCI DSS, for example. In addition to SIM solution, some SIM solutions come by a file integrity monitoring feature exists embedded in the SIM solution. And what file integrity monitoring basically perform is it do monitoring for system files, especially the system binaries, and capture hash value of these files, and continuously monitor the hash values of these files. If one of these files got this hash or got its hash changed, that could reveal some malicious activity, like virus infection happened, and as a result from this virus infection, the virus has appended itself to one of the system files. So using the file integrity monitoring, we can detect such incident. So it is very important to monitor your egress communication because based on egress communication, you can identify if there is a communication with command and control server, if there is someone trying to leak or perform a data exfiltration for your environment, and you can rely on DLP or data leakage prevention to apply such control. Our last slide in this context is the IR automation. And in order to automate the incident response efforts, you might rely on a technology or a product or a technology named or called Security Orchestration and Automation and Response, or SOAR. SOAR is a new security control or an emerging security technology that can allow you to integrate with multiple security controls that can provide detection and prevention capabilities. So SOAR can work as or can support you to create a workflow. So whenever you receive a message from same solution, indicate that someone is trying to perform a ping sweep or scanning over your published services. And this scanning looks like a malicious scanning. Using SOAR, you can create a workflow to allow SOAR to ask the firewall to block this source IP address. So, source solutions or orchestration and automation and response solutions can help you in taking action by integrating security controls together and develop workflows. And based on these workflows, if the condition met, you will be able to prevent the attack. Threat intelligence is a kind of information resources that you can benefit from it to understand what is the new attack tactics, what is the new attack techniques, and what is the ongoing cyber attacks worldwide. So if someone in Europe figured out that there is some IB in one of the countries that is doing malicious activities, using threat intelligence integration and collaboration and communication, we might get aware about such information. So we can automatically ask our source solution to block this IP as well without even see this IP in production traffic. This is how threat intel work. Understanding of the cyber kill chain and the MITRE attack framework, which provide you with information about different stages in cyber attack as well as the indicators of compromise and the tactics, techniques, and the procedures conducted by cyber attacks can help you also in performing incident response automation. Because based on this framework or based on these IOCs or TTPs, you can also benefit in creating workflows in your SOAR. Threat hunting process and the bug bounty program might not be directly related to incident response automation, but it can provide benefit in terms of detecting security vulnerabilities and making sure that these security vulnerabilities are addressed, known, and fixed by your organization. So this concludes the topic related to SOC tools, technologies used, and the overall incident response and incident management process. I hope it was informative for you.